Hi everyone, so we are still in Module 1, but we're on our next standard, GCO 2-5, and this is all about transformations. Before we jump into our level work, there is some background information that I want to give you about transformations, specifically how we can connect transformations to algebra. So let's talk a little bit about algebra. So in algebra, remember when we see the f of x, that means that's function notation. And so we're given a function, and what we want to do is we want to figure out the value of that function for when x is equal to -2. So in this first example, what we would do is we would put this -2 in for x. You can put it in here as well. And so that f of -2, this is not f times -2. This just means I'm evaluating my function for when x is -2. And so now I'm going to put the -2 in for the x squared. Remember, when we substitute values into an equation, we need to put parentheses around it. So continuing, f of -2, again, we're just evaluating this function for when x is -2, is equal to a -2 squared of 4, and then minus that 3. So f of -2, again, all this means is when I put -2 in for x, my function comes out to be a value of 1. So this is function notation. And sometimes we describe functions as input-output machines. So if I have the input of -1 and I put it into the function x plus 5, I would put the -1 in for x. A -1 plus a 5 is a 4, so your output is 4. That's basically what we're doing in these numbers 1 through 3. So we can think of number 2 as an input-output machine, where I want to find f of 5. So what that means is I put 5 in for all the x's. So I'm finding f of 5. That just means I'm evaluating this function for when x is 5. And it's going to be a 5 plus a 7. So f of 5 comes out to be a 12. So again, describing this as an input-output machine, what I did was I put the input of 5 in for x, and I got the output of 12. Now number 3 is a little bit different, because this time they're saying f of x equals 11. So since f of x equals 11, what I can do is I can take this 11 and replace the whole f of x with that number 11. Basically what they're telling you is they're telling you that the y value in this equation is 11. And so now they want you to solve for x. They want you to find x. So we're going to solve this equation by first subtracting 3 from both sides. And I get an 8 is equal to a 2x. And then I'm going to divide by 2 on both sides to get x is equal to 4. So this time they gave you the output of 11, and we worked backwards to find the input, which was 4. So again, we learned about functions. We learned about function notation, and we learned that you can input stuff into equations and find what the evaluation of that equation is when you input the number in. Now, how does this connect to geometry? This connects to something called transformations, which is what we're going to be learning about. So in geometry, we do have this similar input-output process when we determine how shapes can be altered and moved. Sometimes you'll be given a shape on a graph, and I will ask you to move it to a new location. And how we move it to a new location is we use a coordinate rule to take that shape and move it. Or sometimes I might ask you to take a shape and change its size. And again, to change the size of the shape, we would use a coordinate rule to change the size. So when we take a shape and we move it or change its sides, that's actually called a transformation. And we use a coordinate rule to help us transform the figure so it looks either different or it looks like it has been moved to a new location on the graph. Now a transformation maps, we use the word maps, every point of a figure called the pre-image onto a new figure called the image using a rule like the one shown below. So what we do is we start off with a shape that's called the pre-image. And then you will be given a coordinate rule like the one shown below here. And we will take each of our X and Y values from our pre-image, so each of our points from our pre-image, and we will use the coordinate rule to help us find the coordinates of our new shape, which is called the image. And so this is a coordinate rule. This is called mapping notation. And what this means is this rule will move or map all points x, y to its new location. So here we would take every x value and add 3 to it, and we would take every y value and subtract 6 from it, and that will give us our new point on the graph. So we start with our pre-image point, and then we use this rule to help us find our image point. And if you need to pause the video to write all this down, please do. Okay. So prime notation, we use prime notation to identify the pre-image's point's new location on the graph. So therefore, we're using prime notation to mark the image points. For example, if I look at the diagram below, my pre-image is this one, triangle ABC. And then I did something to triangle ABC, and I wound up with this triangle, triangle A prime, B prime, C prime. We are using, that's called prime notation, because your pre-image, we want to label it differently than the image, because if I just label the image triangle ABC, well, I cannot identify which one's the original starting figure and which one was my ending figure. So I do want to label the points differently. Now let's say that I took my image and I transformed it again, and I got something like this. Then I would do triangle A double prime, B double prime, and C double prime. So every time we transform the figure, we just add another prime onto the new sets of points. We're not going to name the points differently. So I'm not going to say triangle ABC and triangle DEF, because then I don't know which point A corresponds to on my image and so forth. So I want to make sure that I use prime notation to determine, oh, okay, A matches up with A prime, B matches up with B prime, C matches up with C prime. So a way that we can show that the pre-image maps onto the image, what that means is if I take the pre-image and I transform it, it will lie exactly on top of the image, is we could use arrow notation like this, where it says triangle ABC, and then we draw an arrow, triangle A prime, B prime, C prime. What that means is that triangle ABC maps onto triangle A prime, B prime, C prime. All right, so we're connecting this back to algebra. So we looked at numbers 1, 2, 3 were the input-output machines for our algebraic equations. Now we're doing input-output machines for coordinate rules to transform a point on a graph. So for example, number 4, I'm given the coordinate rule, this, and I want to determine the image of point A. So point A right now is the pre-image. It is the starting figure. And my coordinate rule states that I'm going to take all my x, y values from point A, and I'm going to add 3 to the x and subtract 6 from the y. Now, a real big, something that I'm not really going to care about is that these capital letters that come before your XY, it can be any capital letter. Those capital letters don't really mean anything. It's just the name of the coordinate rule. So this would be coordinate rule T. This would be coordinate rule G. So you can use any capital letter there. It does not matter. But let's get started with number 4 then. So what we're going to do to find A prime is I'm going to take my x value of -1 from point A, and I'm going to add 3 onto it. And I separate my x and y value with a comma. So I'm going to take my y value of 5 from point A, and I'm going to subtract 6 from it. And so I get A prime. Now I'm just going to simplify. A -1 plus a 3 is a 2, comma, a 5 minus a 6 is a -1. So my new point on the graph after I transformed point A would give me point A prime, which is at 2, -1. So moving on to number 5, this time I have coordinate rule G. Again, it does not matter what you name it. It could be coordinate rule H, it could be coordinate rule C, it does not matter. I'm going to take my pre-image B, and I'm going to put it into that coordinate rule to find B prime. So my x value of B is 5, and my coordinate rule says to do 2 times my x value of B. So 2 times my x value of B, and then comma, my y value of B is 2, and I'm going to add 1 onto it. So 2 plus a 1. So B prime, just simplifying, comes out to be 2 times a 5 is a 10, 2 plus a 1 is a 3. All right, number 6 and 7, this time be careful. We are given our image point, and we want to find the pre-image point, the starting point. So what that means is we want to go backwards. So basically, for this, it's instead of actually just inputting my x and y value into the rule, what we're going to do to find our points is we're going to take our rule and set it equal to the x and y value. So x plus 3 equals the x value of my image, and y minus 6 equals the y value of my image. And sorry, I'm not finding C prime, I'm finding C because I'm finding the pre-image. So now I'm just going to solve both of these equations. I'm going to find my x value. I'm going to subtract 3 from both sides. So I wind up with C, my x value being 3 minus 3, which is a 0. And here I'm going to add 6 to both sides. So my y value of C would be a 2 plus a 6, which is an 8. And that's my answer. Okay. And then the last one, same thing. I'm given my image point. I want to find my pre-image point. So to find my pre-image point, D, I'm going to take my coordinate rule and I'm going to set it equal to my x value of my image, D prime, and I'm going to take my y value coordinate rule and I'm going to set it equal to my y value of D prime. And now solving for point D, I'm going to divide by 2 on both sides. My x value of point D is a -4 divided by a 2, which is a -2. And subtracting 1 from both sides here, my y value of point D is an 11 minus 1, which is a 10. So -2, 10 would be my pre-image point. And you can test this into the coordinate rule to see if it actually works. A -2 times a 2 gives me the image point of -4, and a 10 plus a 1 does give me the image point of 11. All right, so these are called mapping notation. Mapping notation is the coordinate rule that identifies what needs to be done to the pre-image to get the image. All right, so that is your background information for transformations.